In today's lesson, we'll be learning about compound interest, and we are looking at two different formulas. So here's the first formula. And this is when we're looking at compounding a certain amount of times per year. So in these story problems, this one's compounded twice a year. This one is compounded monthly. And then the second one will be talking about continuous compounding. So P is your principal, which is like your starting amount of money that you're investing. Your R is your interest rate. So this is your percentage. And we want our money to grow, so that's why we have the 1 plus. We kind of did that when we were doing the exponential growth. N is the number of compounding periods per year. And then T is just the time in years. So these are pretty easy because you just have to basically find these values and plug them into your formula. So the first one, Brenda invests $4,848. That is your principal. In a savings account with a fixed annual interest rate, so I'm going to write this down. P is 4848, and then the interest rate is 5%, which is 0.05. And then compounded twice a year, that's your N. N is 2. And then how much is in the account after 6 years? So T is 6. So now just plug it into the formula. So A, the amount after a certain amount of time, is equal to your principal times 1 plus your interest rate divided by the number of times it's compounded to the power of 2 times 6, or 12. And then you can just punch it in your calculator. And when you do that, you get that the amount that she will have in 6 years, it will grow to $6,520.02. Okay, same idea. Ryan invests a sum of money in a savings account with a fixed annual interest rate. So this time we've got the R is 4.31%, which is 0.0431. Compounded monthly, that means the N is 12. And after 10 years, so the balance reaches. Okay, so this question's a little bit different. They're saying that's your A. At the end of 10 years, you have this much money. So what was the amount of the initial investment? So let's write it all out. So let's see, we end with 12,855.94 equals P, and then 1 plus 0.043 over 12 to the power of 12 times 10. And we need to solve for P. So really what we're going to be doing is this divided by all of that. And if you do that, you should get that the starting amount was $8,369.34. So starting with this much, with this interest rate and this much time compounded monthly, you would end with the 12,000. Okay, so now this is compounded continuously. So this is every instant your money is being compounded. So this uses this formula. So your P, same thing, is your principal. E, well, E, that's Euler's constant, so that's just the number that E equals about that 2.71. It's a button on your calculator. R is still your interest rate. T is still your time in years. Okay, so when Angelina was born, her grandparents deposited $3,000 into a college savings account paying 4% interest compounded continuously. So every time you want to look for the word continuously in your lesson, and that is your signal to use this formula. And we're going to leave that money in there for 10 years. So principal, 3,000, and then e to the power of 0.04 times 10. Punch it in your calculator. And you will get that at the end of 10 years, you have $4,475.47. Okay, and now thinking about this same scenario, this time it says if her grandparents want her to have $10,000 at the end or after 18 years, how much would they need to invest? So this is your A, and again, we're solving for P. So they want her to have $10,000 at the end of 18 years, but the interest rate is the same. So it's still 0.04 times 18. So to solve for P, we can do 10,000 divided by this. So when you type that in your calculator, you will get that they will have to, if this is what they want, they need to invest $4,867.52 to start. So there is your video on compound interest. Good luck with the lesson.